All right, so welcome to lesson 5. We're going to take a look at grain size measurement and using Python to measure the grains in a micrograph, and then we'll get a grain size number out as well. So we're going to have to do some image manipulation in this one. So I want to go over briefly what the data in an image file actually looks like. So let me go ahead and just load my packages. I think you'll see most of the standard ones that we've been using so far, but with the image we're also going to need to use this CV2. It's called OpenCV if you want to look it up. We're going to use that package for some of the image processing, as well as we'll be using color and measure in particular from SkyImage, and we'll be using ND image from SciPy. And then, of course, from Matplotlib, we're going to be plotting some of our figures, and we'll be using this Matplotlib image. So we've got all those in there. So we're going to go ahead first, and let me just go ahead and read in a data file, and you have this also uploaded for you to use. So we're going to go ahead and read in our Jpeg image, and all I need to do that is the cv.image read. So that'll take care of that, and if this is a PNG or other extension, it'll handle it. I don't need to tell it which extension I have there. So we're going to read that one in, and then we'll take a look at the data for it. And then we're going to look at that image now, convert it into two different forms. One of them will convert the image into RGB, and one of them is going to convert the RGB image now from that conversion to grayscale. So I'll talk more about this in just a second, but let's first go ahead and do that. And here's all my normal plotting from Matplotlib. So we'll go ahead and make ourselves use 3 axes or figures, or plots I should say, within the big figure size. We're going to make 1 row with 3 columns. So let me go ahead and pull that up, and it tells me already I have an error. That didn't take long. Image CV read, yeah, so right here I had renamed that, so that's just actually RGB now. And let's see if that now works. Okay, great, there we go. All right, so one of the things about the CV image read is that it will read in a picture file, and I'll show you in a second what the data looks like inside of an image file. But we have to specify reds and greens and blues for each pixel within an image. Well, image read reads that in as in the order of blue, green, red, which is not typical for what we're used to doing. We like RGB, and the Matplotlib is expecting RGB, and so we need to convert our blue, green, red image from the read to RGB. Okay. And then from the RGB, we can go ahead and convert also to grayscale, because we're going to do our analysis in grayscale for the grains. So those are my 2 conversions. And so I've got all 3 plots here. And you can see that in the first one, the red, the red and the green are swapped with the blue and the green, and so the colors here are not what they should be. So the second image actually shows you what the praying mantis really looks like. He's got a lot of browns in him and some greens in here. This is the real look. This one makes the praying mantis look a little bit on the bluish side, especially under here. But this is what he looks like. He's got a lot of browns. Or she, I'm not sure which one this is, maybe a she. And then we'll go ahead and convert that to grayscale, and so there's my grayscale image. Okay, so one of the differences between the color and the grayscale is the color image has to record for every single pixel in this image. It's got to record the RGB values. So we have a set of 3 values. In the grayscale, for each pixel, it just simply records 1 value. Between 0 and 255 that tells me the gray level. So 0 being black and 255 being white. And that's really all there is to an image. It's just a big array of values. So let's go ahead and look at that a little closer. So we're going to go ahead and take a look at the shape of the RGB image. Okay, and then I'm going to print out a couple of values. I'm going to look at row 10. So I'll come down row 10. That would be all the way, these pixels all the way across. You can see there's over 1,400 pixels across the image. And so we'll go ahead and take a look at that. I'm just going to look at the first 5 values. It's just kind of a little piece right here. So we can see what that data looks like. And then we'll do the same thing with the grayscale. So when I run that, the RGB image, you can see here, it says that it's 996 pixels by 1,430 pixels. So you can see that here on our scale, 996 by 1,430. And so that's the number of pixels. And then this 3 on the end means that at every pixel, I have a tuple of 3 values. That's our red, green, blue. Okay, so we'll look at that. So here it is. So I'm going to go ahead now and print out just 5 values in one of the rows. And so each one of these represents 1 pixel in that image, recording an RGB value. Okay, again, from 0 to 255 now, but first representing red, second representing green, and then blue. And you can see the green values are highest in here. My image is mostly green. Does that make sense? All right, my grayscale image, if I go ahead and look at the shape of that one, right, we're going to see that it's the exact same pixel numbers because it's the same image. We just changed it to grayscale, but it doesn't give us a dimension. Okay, so if dimension is just 1, meaning that each point has 1 number, then it doesn't show a dimension here. It only does that if you've got something other than 1. And so if I go ahead and print the same 5 points as I did here for the color, we get these values here now for the grayscale. Okay. All right, so those are the 2 types of images we're going to deal with. But otherwise, we have now a representation of the image in terms of just a big collection of numbers, of integers representing colors or grayscale. So I could do something like, let me see, we'll grab, let's say we grab this, I'll do it right here actually. Let's say we wanted to plot just part of our image. Well, remember this, this image RGB, again, is just simply a big array with values, RGB values. So we could slice this just like we would do any other array. So if I wanted to plot maybe the head here only of the praying mantis, I'm going to have to do some estimate here. Maybe that looks like it's from what, maybe sort of 200, maybe 180 to well, let's go from 180 to 400 and 1200 to 1400. So let's see if we can get that. So 180 to 400, and then we go from 1200 to 1400. Okay, so again, that should be a box then right about here. There we go, not too bad. All right, so again, we just basically did a regular slice, just like we would any other array of data, and we just told it to go ahead and show it. It's an image. All right, so let's go ahead then and take a look at reading now some data from a micrograph. And we're going to go ahead after we read that, and we're going to do a color conversion to RGB again. And we're also going to eventually turn it into grayscale. All right, so we're going to go ahead and read our image. It's called Grain Size Analysis Jpeg, and This is also in your Canvas folder, so you can play with that if you want. And we're going to go ahead then and convert it to RGB. And we're going to apply now something called a pyramid mean shift filter. This is an interesting sort of filter, and what it will do is it'll take our image, our RGB image. It's going to use a 21 by 21 pixel block, and it's going to go through the image at each point, look in that neighborhood of 21 by 21 pixels, and it's going to take a look at the coloring. And this is a factor that tells it that, you know, any value in the RGB that is within 41 units of each other can be considered the same color. And so it's going to take this image and it's going to kind of remove some of these little spots by replacing it and recognizing that all of this is meant to be kind of the same color. And this works pretty well, so we're going to do that, and then we'll go ahead and just convert it to grayscale, and then do a blur on it. So this is just a way of blurring an image, and this tells it that we want a 3 by 3 block of pixels that it will look at, and then apply a blur. So we will go ahead and do that. Now I should say with this here, this pyramid shift has to take place on a colored image, because that's just the way it is. And our Gaussian blur will take place on our grayscale image. Okay, so we ran that. So let's go ahead and plot all those. All right, so we have several different kind of plots here. First we have our original image that we plotted. So that's what we read in image. Then next we're going to have the grayscale one, which underwent this pyramid mean shift, and then we're going to have a blur. So here's the pyramid mean shift. So you can see kind of the effect here, right? This is one that's got a lot of little darker spots on it, and now it looks like it's kind of one color. So this helps to take out some of the little noise in here, so we don't confuse some of this with being tiny little grains or something when we try and analyze the size of this. So that tends to work pretty well. And then that image is then just blurred. And sometimes the blurring helps. It helps to smooth out some of the boundaries so that we don't try and fit these too rigidly. It also keeps us from sometimes fitting these little spots here, because when they get blurred, then they look a little bit more like noise. All right, something like this you really just have to kind of play with, because it is sensitive to this sort of space of pixels it's looking at, as well as this one with its space of pixels. So sometimes you have to toy with it just a little bit, but you know, as long as you're not destroying the original image and it's starting to look a little less noisy, then you're helping the whole process out. Okay, I'm going to go ahead and stop there, because that's about 14 minutes or so for this video. I don't want it to be too long, so I'm going to go ahead and stop there, and then we'll pick up here and show how to take this image now and to turn it into a black and white image, and then we'll start figuring out how to count each of these grains that are in this image. Okay.